Module 1, Lesson 5, Points of Concurrency. In this lesson, we are going to use our ability to construct angle bisectors and perpendicular bisectors to locate special points in a triangle. These are called points of concurrency. So let's start with some vocabulary here. Concurrent means that three or more lines are concurrent if they intersect in a single point. So we have three lines intersecting at one point. Look at the word here. We've got that co-prefix again, together now, together at this point. That's what concurrent means. And the point of concurrency is the point at which our concurrent lines intersect. Don't you just love math? The lines are concurrent at the point of concurrency. That's just fabulous. This leads us to our theorems for this section. The first theorem is the concurrency of perpendicular bisectors theorem. So what is this saying? This is saying that our perpendicular bisectors are going to intersect at a point. Let's look at the theorem here. The perpendicular bisectors of the sides of a triangle are concurrent at a point that is equidistant from the vertices. So let's look at this. We create the perpendicular bisectors of the sides of our triangle. So let's start with side X here. This is the perpendicular bisector. It's perpendicular and it bisects. And we do side here, it's perpendicular and it bisects. And this side here, perpendicular, bisects. And they all come together at this point P. Right? Three or more lines intersect. There is our point of concurrency. So all we use the bisectors for, the perpendicular bisectors, all we use the perpendicular bisectors for is to find this point of concurrency. And then what's special about this point is that it is equidistant from the vertices. So segment PA, segment PB, and segment PC are all congruent, which means their lengths are equal. Now you should be looking at that and going, we have a central point and three congruent segments. That looks like something that we can use. The circumcenter of a triangle is the point of concurrency of your perpendicular triangles. So this point is called the circumcenter. The circumcenter is equidistant from the vertices, so we can use that as a center of a circle that contains each vertex of the triangle. Now we say that this circle is circumscribed about the triangle. Look at that word. That word tells you what it means. Scribe means to write. Circum means to go around the outside. Think of circumnavigate the globe. Circumference of a circle. So we are drawing a circle around the outside. So we have the circumcenter here and our three radii that go to the vertices, and that's going to allow us to draw a circle that passes through the vertices. Pretty cool, if you ask me. The circumcenter can be inside, on, or outside of a triangle. If you have an acute triangle, it's inside. If you have an obtuse triangle, it's outside. And if you have a right triangle, it is on the hypotenuse. So very exciting. Our next theorem is the concurrency of angle bisectors. So what does that mean? That means our angle bisectors are going to intersect. So the bisectors of the angles of a triangle are concurrent at a point that is equidistant from the sides of our triangle. So we draw our angle bisectors. We bisect B, and we bisect angle A, and we bisect angle C, and we end up with a point of concurrency. Now, the only reason we really care about those angle bisectors is to get that point. Because what's important about this point is it is equidistant from the sides of our triangle. So I can draw a line to this side of the triangle, this side of the triangle, and this side of the triangle, and I know that those lines are congruent. If those segments are congruent, then they have equal measures. Now, the in-center of our triangle is the point of concurrency of our angle bisectors. So this one is called an in-center. It is always inside the triangle, and it allows us to inscribe a circle in our triangle. So let's take a look here. We have our in-center, our point of concurrency of our angle bisectors, our in-center, and we know that it is equidistant from all of the sides. That is going to give us a radius. We have all of our points here, and we can inscribe a circle. So we use our angle bisectors and our perpendicular bisectors to find special points in a triangle. We are going to construct the in-center of our triangle. This is the point of concurrency of the angle bisectors of our three angles. We can do it with two, but we might as well do it with all three. So we need to construct the angle bisectors, and you remember we do that by taking our compass. We create two intersection points using the same radius just because it's easy. We find the intersection on the interior of our angle, and then we take a straight edge using this intersection point and the vertex of our angle, and we bisect that angle. And then we are going to do the same thing for the next angle here. Two intersection points, use the same compass setting, find the intersection on the interior of our angle, use our straight edge to draw the angle bisector, and we will do the same thing for our third angle here. Intersection points, use our same setting, find the intersection point on the interior of our angle, take our straight edge, draw our angle bisector. Where our 3 points or 3 angle bisectors intersect is our in center. We have the 3 points that intersect our triangle, and we are going to use that to make our compass setting for the radius of our circle. That's not bad. That's pretty close. We have constructed the angle bisectors of our triangle, which gives us the in-center, which allows us to inscribe a circle inside of our triangle. That was fun. We're going to construct the circumcenter of our triangle, and we do that by constructing the perpendicular bisectors of the sides of our triangle, and we do that using our compass. And if you remember, we set our compass to at least more than half of the length of the segment. I am just simply going to use the length of the segment because that makes my life easy. And I construct the arcs of the circle that are going to contain that line that runs through the center of my segment. And then I come over here using the same compass setting, and there are my arcs. I'm going to take my straight edge and connect my intersection points, and that gives me the perpendicular bisector of that side. And I'm going to repeat that process with the next side, and I simply draw the arcs of the circle that are going to contain the line that bisects that side. Oh, set my compass here. Draw those arcs, get my intersection points of my 2 congruent circles, use my straight edge to connect the intersection points, and that gives me the perpendicular bisector of this side. There we go. And 2 points is enough, but we'll do the third side just for practice. It's always fun to construct perpendicular bisectors. So I'm going to draw the arcs that contain that intersection line. And there's my other congruent circle. Take my straight edge and connect my intersection points. And that gives me the perpendicular bisector. And we now have point of concurrency, the circumcenter, where my 3 perpendicular bisectors intersect. And I am going to use the vertices of my triangle because we know the circumcenter is equidistant from those vertices, which means I set my compass on the circumcenter and to the length of one of my vertices, and I can circumscribe a circle about my triangle. I constructed the circumcenter using my perpendicular bisectors, which is equidistant from the vertices of the circle, which allows me to circumscribe a circle about my triangle. That was fun. What a fun use of our construction techniques. I hope you enjoyed it as much as I did.